Hello guys, welcome to Yummy Math, and this tutorial is about quadratic equations. The topic is nature of roots. So we all know that the roots of quadratic equation ax square plus bx plus c is nothing but alpha equals to minus b plus under root of d, which is discriminant, and beta equals to minus b minus under root of d by 2, where d is discriminant, b square minus 4ac. Now let me draw the graph again, because it's easy to understand from graph. X, y. So let's draw all the three use cases. So this is d is greater than 0. So when you have real roots, that is when the curve is intersecting x-axis, you have real roots and d is greater than 0. When the curve is touching the x-axis, d is equals to 0. You have real roots, but both the roots are same. So we say real and equal roots. When the curve is neither touching nor intersecting, equation doesn't have real roots and d is less than 0. Right? So let's take case 1 when d is equals to 0, right? So alpha is nothing but minus b plus the root of d by 2a, and beta is minus so when d is greater than 0, the equation has real and distinct roots, which are given by these formula. Case 2 is when discriminant is equals to 0, the equation has real and equal roots, right? Which means b square minus 4ac equals to 0. So when discriminant is equals to 0, this goes off, right? So let me rewrite it. Alpha becomes minus b by 2 and so in this case alpha and beta both are equal, and they're equals to minus b by 2a. Now third case, when discriminant is less than 0, that is b square minus 4ac is less than 0, right? If discriminant is negative, then this can't have a real value, right? So in that case, the equation, so in this case, equation doesn't have real roots. Okay, so I want to tell you one more interesting thing, which is not yet covered. It's not related to nature of roots. Let's say the equation is ax square plus bx plus c equals to 0. This is the equation. So the sum of roots and product of roots. Okay, this can be asked in multiple choice question, right? So this is important thing to remember. So product of roots is nothing but c by a, and sum of root is nothing but minus b by a. Just remember this. It can be useful to you guys in any of the multiple choice question. Let's go through some problems on nature of roots. So first example is determine the nature of root of this quadratic equation. So let's quickly write down the values of a and b and c. A is 1, b is minus 4, c is 4. Therefore b square minus 4ac minus 4 whole square minus 4 to 1. Okay, since t is 0, therefore roots of given equation are real and equal. Next example is find the value of k for quadratic equation for which this quadratic equation has real and equal root. So let's find out the discriminant. A is equals to k, b is equals to minus 5, c is equals to k again. So t is nothing but b square minus 4ac. Putting these values we get minus 5 whole square 4 into k, which is nothing but 25 minus 4 k square. So this equation will have real and equal roots if discriminant is 0, which means 25 minus 4 k square is equals to 0, which means k square is 25 by 4. Therefore k is nothing but plus minus 5 by 2. Never ever forget putting plus minus whenever you take under root of a square term. So k is equals to plus minus 5 by 2. Okay, find the value of k for which the following quadratic equation has distinct real roots. Okay, which means discriminant should be greater than discriminant should be greater than 0, right? So here a is equals to 1, b is equals to minus 4, c is equals to k, b is equals to b square minus 4 ac. Which is nothing but 16 minus 4k. Therefore 16 minus 4k is greater than 0, which means 4 which means 16 is less than 4k, which means k is less than 16 by 4. Therefore k if p, q, r and s are real numbers such that pr equals to 2 times q plus s, then show that at least one of the following equation has real roots. Okay, this is interesting. So let me name this equation. This is 1, this is 2. Now d1 would be p square minus 4q and d2 would be r square minus 4s. Let's add d1 and d2, which is nothing but p square plus r square minus 4q plus s, right? And from here we can say that let's take 2 in denominator, so q plus s equals to pr by 2, right? So replace q plus s by pr by 2 here. P square plus r square minus 4 pr by 2, p square plus r square minus 2pr, which is nothing but a perfect square. P minus r will always be greater than or equals to 0. So this term is always greater than equals to 0 for any real value of p and r, right? Means at least one of the discriminant d1 or d2 is greater than or equals to 0, right? Which means that at least one of the two equation has real roots. Okay, if minus 5 is the root of quadratic equation 2x square plus px minus 5 equals to 0, and the quadratic equation this has equal roots, find the value of k. So let's use this equation first. It says minus 5 is the root of this equation, so this should satisfy this condition. Let's put minus 5 in place of x, which is nothing but square minus 5p minus 15 equals to 0. Solving this, it gives p equals to 7. Now put this p in this equation. We get what we get. We'll get 7x square, 7x square plus 7x plus k equals to 0. Now this says that equal root. This equation has equal root, which means, what does it mean? D is equals to 0. B square minus 4ac is equals to 0. Therefore 49 minus 4 into 7 into k equals to 0, which means k is equals to 7 by 4. Guys, if you like yummy math, please write a review for us on our Facebook page, which is facebook.com/yummyymath. And if you have any doubt or question, please post it in the comments section at the bottom of this page. Thank you. Bye bye. See you.